This is the Blink from Dishonored, and this is our implementation in Unreal Engine. Every tutorial I've come across focuses on teleporting the player from A to B, but that's not what makes the Blink feel correct. Blink isn't a teleport, it's a movement system with strict collision rules, surface validation, visual anticipation, and performance constraints. In this video, we're building it the way a studio would. Clean architecture, edge case handling, proper collision resolution, and smooth movement that matches the game. It isn't going to be a 10-minute trick. This is how we teach at HardEdge. Real systems built properly. In this specific video, we're going to focus on the gameplay aspects of the Blink from Dishonored. This is part of our TechArt course, specifically the blueprint module, and so some blueprint knowledge is required, but I think anyone can follow along. The way that we teach here at HardEdge is that no stone is left unturned. I will explain absolutely everything that I can, and this effect is really all about collisions and some vector math. If you are new here at HardEdge and you don't know me, my name's Filippi. I am a technical art director currently working in AAA games, and HardEdge is our industry prep academy. And I'm here to teach you everything I know about tech art, game dev, and game art. Okay, so the first thing we need to do is just to add an extra input to our character so that we can blink. We'll do this very quickly. We'll go into input, create an input action. We'll just follow Unreal's naming convention and it will be IA blink. We don't have to do anything to this file. The blink actually works on a right click press. You don't have to hold it. Like, you can hold it, but you can press it and it will instantly blink. So we can just leave it as default there. And if we go into the input mapping context here, we can add the mapping for the blink by doing so. And what we'd like to do is just use the right mouse button for this at the moment. That is all that you need to get started when it comes to input. Okay, so the first thing that probably anybody's going to teach you is that you're going to open up the player and you're going to start filling it with variables. Don't do that. Just don't do that. That's not how things should be done. That's not how things are done in studios. And in order to make this a proper bit of code, you want to separate all of these responsibilities that come with blinking into a component. So that's definitely what we're going to do. The first thing is to specifically create a actor component, and that's where everything is going to live. So we're going to do the actor component, and it's going to be a AC for actor component. You can do BP AC or something like that if you like. I do AC for actor component just to make it easy for this case, and we're going to call it a blink component, like so. And now that we have this, this is where everything is going to actually happen. And so when we want to do our input action for IA blink, which is over here, this is where it will happen. We will actually do it inside the component because it actually makes sense. Now, the first thing that we need to do really is to place our preview actor into the world. And in order to do that, what we want is to sort of pre-spawn this preview actor, right? Another very common mistake is that you would just like spawn it when you hit the button and then delete it when you let go of the button or something like that. Don't do that. That's wasteful. So you want to reuse resources as much as possible because we're mindful of performance. So what we're going to do is we're going to actually spawn it. We're going to keep a variable to the object that we've spawned, and we're going to manage its visibility and things related to it inside this component. So let's do that right now. Well, we need to spawn an actor from class, and oh, hold on a minute, we haven't built an actor that we're going to spawn. So let's do that right now. The blink is going to just I'm just going to put everything here in this first person blueprint section. So I'm just going to make another blueprint. The thing to remember is if you want to know what you're going to build, if it's going to live in the world, it is an actor. That is just the rules. So it's very important to kind of know what kind of blueprint that you want. In our case, it's going to live in the world. It's an object with a transform. It's an actor. So we're going to right click blueprint class. We're going to make an actor, and we're just going to call this BP Blink preview. And that should be fine. And in here, what we're going to do is we're going to add a few things. We're going to add a sphere. If I could type, we are going to add a cylinder, and we're going to add another cylinder, and this other cylinder we're going to actually parent under the sphere. So this first cylinder here will be our sort of bottom piece, and it'll be kind of hard to see, but we will sort this out in a second. I'm going to turn off all the snapping because it is making things difficult. So there we go. That will be enough. So that is the top of the cylinder here. The effect in Dishonored is almost like a little vortex or a hurricane. We'll get into that when we do the VFX. So it's just important that we are zeroed out here. And then the sphere itself, I'm going to make sure that it's here. That's basically the object that is going to be the preview one. So we're going to compile and save, and that's what we'll do for now. And now we get to just say that we want the blink preview actor as the thing that we spawn. We will store a variable of this, so we will just call this blink preview. And what we can do now is consider, how is this going to work? Well, it was very simple. We want to place this in our crosshair, or in this case, we don't have a crosshair, the center of the screen. In order to do that, we need to get the center of the screen and decide the distance that the blink will sort of happen in, right? For that, we need to take the camera position and project it forward. How this is going to work is very simple. The camera has a position vector right here, and it also has the vector that it is facing. So in this case, the camera is facing in that direction. And we can get this in blueprints. And what it will return is what we call a unit vector. And a unit vector is a vector with the length of 1. And that's what it's going to be. It's going to be exactly that. So you're going to take the camera position, you're going to take this unit vector, you're going to add them together, and you're going to get this. It's hard to see, but you get the point. But what you can do with vectors that's sort of like a special thing is you can take a vector and multiply it by a float, and that is called vector scaling. And when you do that, let's say we increase this by 100, 100 being 100 centimeters, which is exactly a meter, well, you will take this vector and transform it like so. So when you add these two together, we do what is called tip to tail. So this vector is here as well. This position is there. And what you do is you take the tip of this vector and you add it to the tail of this vector. And then what you end up with is that. And that is exactly how we're going to do this system. Okay? Very simple and very fun, foundational, if I do say so myself. Let's go back to the blink component and let's do this. You do the get player camera manager. From this, you will get this actor's location. This is that vector on the camera that we talked about. And then what we can do is we can get the forward vector of this actor, which will immediately grab the transformation component of this object so that we can find its forward vector. We will take the forward vector, we will multiply it by a float. You can right click any multiplication here and change from float to single precision or double precision. I will pick double precision in this case. And we will decide a distance. And in this case, I will do something like 8,000. So we're going to add these two together now. And what we can do is we can do a line trace. Now, it's important to understand something here. And what you want to understand is that the input is processed every frame. So effectively, this is a tick. That means when we are coding this, we should be super mindful of any wastefulness. Let's put this over here. And what we can do now is the start will be the camera location, and the end of the trace will be the sort of multiplied vector here. I will draw a debug for one frame, and we can now compile and save. We will get an error because you cannot spawn something without a valid transform. This pin is not valid unless you split it or give it an actual transform. The keen-eyed among you would have noticed that we never added this component to the character. So let's do that. I'm going to look for AC, Blink component, and I'm going to add it to my character. Lovely. Now, if I hit play, I can right click and I should see a line trace. And you can see there is our line trace. And it is working as we expect. Center of the screen, doing exactly what we want. So instead of just actually doing a line trace, what we can do is we can turn off the debug now and we can break this struct bin. I will again mention that this is effectively tick and blueprints are slower than C++. In the third part of this tutorial, I will nativize all of this code into C++ to show you the performance difference, and it is significant. So just keep that in mind. Doing this that we've just done here by splitting this struct pin for the hit result structure means we are actually doing a copy effectively so that we can get all of this information. And it is expensive, so not ideal, but it's okay. So what we want is the hit location, I guess, to set the blink preview. So we take the blink preview, we take this new actor in the world, and we say set actor location, like so. And we feed the location that we want. We connect the nodes. We say we wanted to teleport there. And we should now have our blink preview actor visible in the world. There we are, as you can see. Oh, and it's behaving really weirdly, right? Oh my God, what is going on? Well, it's really important to understand that when you add static meshes to a blueprint like this, they have collision. Static meshes have collision by default. So I want to show you everything that's going to go wrong so that you're not afraid to fix it. We're tech artists here. We want to know how things work. We want to fix things. So that's the thing we need to do here. So the collisions were preventing things from actually showing up where they should. And now if I right click, I should have the little preview actor working, which is great news. It is basically working, which is pretty all right. Now, you can see here that specifically it's disappearing, right? It's disappearing no matter what we do. And the reason it's disappearing is because we've hooked it into a hit result. And if there is no hit, well, where is it going to go? Well, if there is no hit, we should really go on the end of our line trace. So what I'm going to do here is I'm actually going to promote this into a variable, and we're going to call this blink trace end. We're going to connect it over here. And now what we can do is connect this over here. And if there is no blocking hit, which we will check here, what we can do is, well, there's two ways of doing this. You can do a select from a vector like this, and if you have a blocking hit, you can do it like this, or you can do a branch and do a true or false path. It is up to you how you decide to do this. I will, for now, do the select vector because I think it will work. So if you do have a hit result, you pick A. That's what this means. So we pick the first option if it is true, and if it isn't true, we go for the second option, and that's what we would like to do there. Okay, so already we have something here. We're doing this little select, and we can see how that works. So if we come over here and hit play, suddenly it works as we expect. So when we hit things, it goes on the hit surface, and when we are on the floor, it will stay on the floor. So already that's pretty good. And then most tutorials, oh, and did you see that? When I let go of the button, it just stays there, which we don't really want, right? So let's fix that right now. So on the completed or canceled, because you can actually cancel the blink, but we won't implement that here today. What we want is to hide this blink preview. So I'm going to get this blink preview and I'm going to hide it. Now, I don't want to just come here and like set the visibility of this actor and be done with it. There's actually going to be a good amount of stuff that we need to do when we turn this off. So what I'm going to do is give this object responsibility for itself. So inside the blink preview, we're going to come in here. I'm going to create a custom event. And we're going to call this activate preview. And we're also going to create another custom event if I can. I'm going to call this deactivate preview. And this one got a bit cross with me for some reason. The main thing we're going to work on is just making things visible or invisible. So let's take all of these things here, and we would like to set these as hidden. So we will set hidden in game. The new hidden will be true, and you can connect multiple pins to this, and it should work just fine. I will tick propagate to children only because there will be objects with children. So for example, you could just do the sphere and ignore cylinder 1, and then it will actually do it for both. So there we go. But now when we activate the preview, well, we should probably actually do something here, right? We should do the set hidden in game, but we should do it differently. And what we want here is to be mindful of what's going on. When I let go of my click, this will happen, and that's fine. So let's do that now. So when we're completed, we can get the blink preview and say deactivate preview like so, which is pretty good for me. And when it's canceled as well, that'll make sense in the future. So now what we can do is when things are happening here, we can then do the activate preview. However, remember, this is effectively running every frame. And because of that, doing wasteful operations is a bad idea. So we want to only set these things to be visible if they're not visible, right? So the first thing that you need to do is check if things are already visible, okay? So we can check if the sphere is visible, because if the sphere is visible, a bunch of other stuff should be. And we'll just go in here, is visible. And if it is visible, then we sort of skip and go into like whatever we do here, which we will do a lot of stuff in this blueprint very shortly. But if it is invisible, there we go. We unhide things, and that should be what we need. So we're not being wasteful. So we block things as much as possible. Be super mindful of your performance. It really will come back and get you if you just follow a bunch of tutorials and don't think about what you're doing. Cool. Now we need to go back to the component and actually do activate preview. So I'm going to get the blank preview here, and I'm going to do activate preview. And we would like this to happen over here. Even if it doesn't look like we've done very much, it now works pretty well. And as you expect. Cool. And at this point, what would happen is when you blink out, well, every other tutorial is going to basically say, well, you know, all you've got to do now is you just come in here and say, um, you know, set actor location for our owner. So get owner and the get actor location. Or what we can do is instead of getting it, we can set it. So we go set actor location, and the new location should be the this vector here, wherever it is, right? So this vector here is actually quite important. So we're going to promote it to a variable, and we're going to call this the blink destination, right? That's important. Or I think in this particular instance, I'm going to call it blink preview last location. Okay, this will come into effect more in the future, the reason I'm naming things the way that I am. So now we need to just set this thing here and do that. And then, you know, oh, look, let's just hit teleport and will it work? Yes. Wow, cool. We've done Blink, everybody. The tutorial's over. But this isn't how Blink works. The way the blink works is that we actually move through the space and get blocked. A teleport does no collision checks, but the system works, and that's what we want, right? Like we want to be able to do things like this and, you know, be confident that our blink is working. And it is. And it's important to always kind of prototype things and verify your situation. So that feels pretty good, and that works quite well. So that's great. The reality, though, is that we want to sweep. And sweeping actually means that our collision will be swept across the world. What will happen is we will take this collision capsule, and let's say the blink destination is over here, right? And that is a terrible color, so we're going to pick this color instead. So let's say the blink destination is there. What we want to do is, and the teleport literally just places us there. That's that's exactly what happens. A sweep, however, will try and move the capsule through the world until it gets to that destination. And so if you sweep, there's a very large likelihood that you'll get stopped right there. Or you'll get stopped there, or you'll get stopped there, or you'll definitely get stopped here. That's what a sweep will do. And the problem is that we can't have that happen. And that's our first challenge to solve is how do we go about this? So I have it on a sweep. What does it do when we hit play? As you can see, I get immediately caught. Unless I'm up in the sky, I can't actually move anywhere because of collisions. So then what folks would say is, well, you don't need collisions, right? Take the sweep off and it will behave exactly like Blink does, right? There you go. You know, it's working. But it isn't working because we are still teleporting. And that is not what we do. Moreover, as you can see, we'll get stuck whenever we have a failed collision check. So the first thing to go ahead and do now that we have something to implement is things are going to start to grow and blueprints will get messy very, very quickly. And I'm not going to be super, you know, hard line about all of the lines need to be straight and pretty and beautiful. I don't really care about that. We're trying to prototype. Let's move with speed. We can make it pretty later, right? But I'd like to, at the very least, tidy this up a bit. So what I'm going to do is I'm going to do a couple of custom events. One of them is going to be handle blink, for example. And what we can do is we can connect these here. And I'll just move this below. And what that means is I can actually just out of completed call handle blink. And that's good. And then out of triggered, I could also do something like a custom event that says, you know, enable blink preview, something like that. And I can also move this aside and go from there. So that's what I'll do. So on triggered, we will enable blink preview like this, right? And it's just going to allow us to be a little bit freer and disconnect a bit from that input, which I think is a smart idea. So we're going to move that over here. The first thing we're going to need to do is to add some sort of a gate so that we can't spam the blink endlessly. And for that, we're just going to add a simple Boolean called blink active. And I don't really need to do anything else with this apart from we need to set it as active when we are doing things. And then once we finish doing things, we need to let it go effectively. So we're going to do this for now. And then what we can do is at some point here in the end, which we will do some more work in a second, we need to deactivate the blink. And then we can only really do this here if the blink is not active. So we just take blink, get it, do a branch, and go from there. So like so. If the blink is not active, we can do the preview. That's it. And for sake of argument, we'll just do a simple delay now. And this delay will be of 2 seconds. And after we finish blinking, we can't blink for 2 seconds. There you go. That's all we'll do. Okay. You don't have to do this, but it's just to demo a simple gate functionality. Right. So what we need to do is match the movement so that it represents what happens in the game. In order to do that, we need to actually lerp between positions. And we're not quite ready to do that with all the functionality that we still have to build, specifically to do with ledge climbing and things like that. So I'd like to, for now, just show you how a timeline would work, and we'll get it sort of in place, and we can sort of go from there. So we'll leave it here. I'll move this section over. And what we can do is say timeline. And here's where we'll immediately hit a problem, which is we cannot have a timeline inside of a component. So that's it, right? We can't do a timeline. The tutorial's over. I can't do it. Um, well, no. So the thing to keep in mind is that obviously this is a tick, but we are trying to do something when we let go, so we can't leverage this, unfortunately. And we can't put a timeline in here, but we could put a timer if we wanted to. We could also put a timer on the player itself, or a timeline in the player itself, and trigger things from there, which is a bit clunky and I'd rather not do. So what we're going to do is use tick. And I know you're probably looking at this and like, oh my God, there we go. Here it is. We're using tick, bad tutorial, unsubscribe, click away. And listen, I want to be clear and say that a timeline is a tick, and so is a timer, and so is the input trigger. Using tick is not a crime, and using tick means using tick responsibly, and that's what we're going to do. And you just have to be aware that using tick and doing too much on tick can be a problem. This is a way that is, I guess, people shy away from because it is more complex, but it's a very valid way of doing things, which is to use a curve. So let's do this. You're here to learn new things. So maybe you've never used curves. Curves are really powerful. So I'm going to create a curve float, and we're going to call this the C for curve, and we're going to call this the blink curve, like so. Now is the time to add our keyframes. So we're going to go ahead and add a key at 0. And this key at 0 will be at 0. And then we will add a key at around, I don't know, 0.3 or something like that. And what I'd like to do is at, say, 0.3 or something like that, we're going to be at 1. And then we're going to add a key right in the middle, or thereabouts in the middle. And we're going to just take all of these keyframes and we're going to set them to auto so that they're smooth. Now you have a lot of functionality here in this curve editor. You can do a lot of stuff to it. You can also automatically apply things to it. So you can kind of blend the values. Like, so for example, you can slide things around. It's really, really useful to kind of get what you want. But what I like to do here is put it in a normalized view so we can really see the actual curve that we have and how I want to control it. So what I'd like to do, and you can see here, it's difficult because we have such a small increment to work with. So we can really play around with this. And what I'd like to do is probably, I'm going to make it quite sharp. There's a small buildup and then we'll kind of go. So something like this is the curve that I want for my blink, which is great. Now you need to drive this curve through tick, and there's a bit of complication there, but this is an advanced tutorial, like I said, so hopefully everything is, for now, making sense. We'll add a new variable to our component. It will be our blink curve. And this object that we're looking for is a curve float. Here we go. And we can just hard code the curve float in there. Like, that is not a problem. If different characters had different blinks, you could change this. It's completely up to you. It's not really relevant for what we're trying to do today. Okay, so we're going to need a few things to make this work. The first thing is we need to decide our timeline length. So I've decided to shorten this a bit just so that we can make this a little bit faster. So 0.24, that's an important number. So we're going to go ahead and say that this is our blink duration. Cool, so we have that. We also need a few more floats. We need blink start time. And we need, well, we have the trace end, we have the preview last location, we have the things that we need. So this should cover us for now. The first thing we need to do is set everything up so that our tick can do what it needs to do. This all makes sense. However, we're not going to set the actor location here we're going to do something a little bit different. The get owner is important, and the get actor location from the owner is really important as well, because this needs to be our sort of blink start. So we do need to save this into a variable. So we're going to go ahead and say that this is the blink, I guess, start location. We will set this variable, go from here. Now, the next thing that we need to do is to get the time currently when we've let go of the button. So when we do let go of the button, and you'll see I'll have to keep like moving this comment box. When we do let go of the button, we need to get time. So this is what we'll do. We'll say that we'll get world, and then we'll say, can we get time seconds? There we go. We can do this, get time seconds. That should give us where we are. And this is our sort of start time. So we'll promote this variable as blink start time, like this. Sorry, this is, we can set this variable to be the blink start time. So we will do this and set it like so. And there we go. And then the next thing we need to do is go into the class defaults here, not start with tick enabled, because we only want to tick when blink is doing it. And this is a good thing to do, manage your ticks. So now we can go enable tick is component, set component tick enabled, and we will enable the tick now. And now that this is done, we can continue with everything else that we are going to do. So all the rest of the setup, which is in our case, we should set the movement scale to flying. That's going to come into play soon, especially when we're on ledges and things like that. So we'll do set movement mode. And we can't, right? Because we need things from the owner. And that's the sort of part where we have to understand that we're going to call a bunch of functions, and this is our setup for the blink, right? So we can do this on begin play, so we're not paying a cost every time. So that's what we're going to do. So whenever we get the owner, like for example, this is a pure function that gets called every time, but we should know who the owner is on begin play. So let's do that. So we're going to go get owner, and we're just going to say that this here is the player, like so. And that's just going to make things a lot easier. The other thing that we can do is, because this is an actor, what we can do is, instead of doing it like this, you could cast to character like this. And because we know it's a character, we know it's not going to fail. We're going to promote this to a variable and say that that is the player. And now we have two birds with one stone, because what I can do is I can just get the character movement component like so. Very easy, right? So that's what we will do. So instead of owner, we'll get player. So we kill a pure function there, which is great. And let's see if we have any other ones we need to do. We don't, so that's good. And now, because we have the player, we can come in here and we can say, hey, get player, and we can do get character movement. We can say set movement mode, actually, and then you'll see that it'll give us the option of getting the character movement. So it'll do both nodes in one go. And we'll set it to flying. Not falling, flying. Thank you. And there we are. Okay, so now tick is enabled, which means as the tick is active, other things are going to happen. So effectively what this is doing is saying, hey, you know, blink is activated, tick is now going to run, you know, so gather all data, run tick, for example. And then here is, after everything is active, is where you would disable things such as this, and you'd go back to walking, for example, get the player, do that, do something like this, right? So it's kind of like your reset after the blink. So something like this, we come in here and we say reset. So hopefully you're with me and this is making sense, right? We're sort of prepping everything that we're going to do, and now we're going to do the heavy lifting, which is using on tick. So we first check if the blink is active or not active, right? So we have to kind of decide here how we're going to do this. So when the blink is not active, we do the preview, and when the blink is active, we can tick. So that's our first gate, which makes sense, right? So we come in here, we get blink is active, and we do a branch. And if the blink is active, cool. We are now cooking with fire, and we are ticking. Before we continue with the branch though, I would like to make sure that our blink duration, which we should have a default value for, is matching our curve. So I'm going to set the blink duration to be the end of the curve so that I can tweak the curve and know that this value will always be what we want it to be. So I can get the time range and get the max time, and that will be the whatever we set the curve to. And obviously we had set it to 0.24 or 0.23, and in between pausing the video and stuff to have a drink of water, I decided to play around with the numbers, and I think 0.34 is better. But you can choose to do whatever you want with this, and now on begin play, programmatically, we will set the blink duration, the amount of time it takes to get to point B, automatically via the curve. So that's a really important thing for us to mess around with, okay? Okay, so what we need to do here is we've got to get the time seconds and see how long has passed since blink has started. That's the first thing we need to do. And there won't be any time, but that's fine. So we will subtract this here. And what I'd like this to become is a variable that I've created here, which is called elapsed time. So how much time has actually passed? So I'm moving a little bit faster here because I'm mindful of time as well, because this is a very long video already. And with elapsed time being taken care of, what we can do is we can divide this by the actual blink duration so that we know how to drive the curve. So now we can get the curve and we can get float value. And the idea here is that we can clamp this value. So we can clamp this float from 0 to 1 so that we don't ever go past the end of the curve. And if we do that, we now have our timeline. And we can now lerp our vector. So we can do a lerp vector. And we can take the blink start location, and we can take the blink preview last location, and we can feed this float into the alpha. And then what we can do is set actor location. And it won't allow us to do this unless we have the player. So we grab the player and we'll do set actor location. We will not do any collisions. You'll understand why soon. We will leave sweep off, and we will not teleport because that is not what we're putting all this effort into. And what we can do now is connect that. And what we have is a timeline that we can dynamically control based off of this one float curve. And this is a great pattern for you to mentally have in your head. You don't need timelines, just use tick. And I will die on that hill as something that is very doable, very usable, and arguably cheaper. So cool. What we need now, though, is to stop this when we've reached our destination. So it's very important that instead of doing the movement mode to walking over here, what we can do is we can set our movement mode to walking at the end once we've reached our destination. How do we know where we've reached our destination? Well, the easiest thing to do is to use this float value, and when it reaches 1, we will be okay. So if we do greater than equal to 1, then what we can do is just set the movement mode to walking and also stop tick. That's really important. Enable tick. Set tick enabled to not enabled immediately so that we can stop moving. That's what we want to do, and that should work quite well for us, I think. And What I want to make sure though is that like this doesn't keep getting called, um, once our destination is reached. We'll double check this later, but this should work for us quite nicely if I do say so myself. So let's compile, let's save, and let's see what happens. So we will play, and there we go. Now, there will be some weirdness with collisions because we're not checking collisions. So what's happening is we're getting stuck on the floor and then the collision's popping us up. That's fine. That's expected. We're going to fix that next. Okay. But already you've learned multiple things and now you know how to replace a timeline with tick. Okay, so I've gone ahead and just done a couple of bits to show you what you can do with the system now. I have gotten a few extra things on begin play. So just to kind of bring you up to speed so you can make sure that your graph looks like mine. On begin play, I am now getting the player, I get the capsule component, I store it into a variable, I then get the capsule radius, the scaled one, and the half height, also store these two into a variable. And then after the blink duration is set, which you have already done, I'm also taking the player variable here, right? We've got the player over here, so I'm just using the variable over here. And I'm doing get component by class and getting the camera component. And I'm storing the camera in a variable. The reason for that is that once you have the camera, you can set the field of view. So you could take the camera here and you could say set field of view. And what we can do is because we already have a timeline or an alpha to use, we could lerp a float, which is just a regular lerp here. And then you could do something like 150 to 90 and feed the alpha in here to drive the camera. And that's exactly what I have done in the current state of affairs here, which I think looks pretty cool. And so just wanted to show you how my tick is looking right now. I haven't done anything. I've just reorganized it and I just wanted to quickly go through it so we don't waste loads of time. So you can see here, I have taken the clamp float and I've just set it into a variable just so I don't have a bunch of, lines going multiple places. And that way I'm not calling a pure function multiple times on a type of execution loop such as tick. So that's a good thing to do. So we take the lerp alpha, and the other thing I've done is I've stored the blink location as the sort of, as we lerp, I'm storing where we're meant to go. This will come into play very shortly. And here's where my camera stuff is. I've just inputted right after the set actor location, and the set actor location is just using this variable here. So that's all we have, and hopefully that makes sense. You can see here, once the alpha reaches 1, I'm setting the field of view to be 90 just to make sure. And then I'm disabling tick, setting it to walking, and I'm setting the blink to be deactivated. All of this really should be moved into a custom event called deactivate blink. And that's exactly what I'm going to do. So I'm going to go here, deactivate blink. You're all caught up with me now. I just wanted to kind of do this quite quickly so that we don't waste loads of time doing the camera and etc. Right? So that makes sense. Now I want to do the final bit of movement for the character, which will be at the moment a capsule trace. And so this is why I'm getting the half height and the half height and the radius, because we're going to do a capsule trace. Why are we going to do a capsule trace? We do a capsule trace because the player character has a capsule in it. And what we want is for when this character, which is here, when we have the blink going over, let's say it's meant to come over here, I would like this capsule to kind of do that, right? But if we were going to move linearly, we would hit this, right? And I don't want the floor to stop us. I want us to kind of come above the floor and then do this. But if there's anything that should block us sort of like tall enough, I want that to stop us. So I think the best way to explain how the capsule trace is going to work is to have done it and then show you, okay? The biggest issue that we have is that we've got to clear these gaps. And so what I've done is I've pushed the player up when we're going to do these traces. So we take our position and it's almost like we hop. So before we blink, we're telling the capsule trace to basically do this and try and find us a clear path. And that's exactly what it's doing. So what I do here is I take our position that's on the ground. I then add about 2 meters to it, so something like this. From that, I will then say this is the starting position to find our line. How do we get there? Because obviously, if we're here, we're going to hit that, right? We don't want this. So we add a further sort of 65 units on top of it. And from here forward, we sweep a capsule in the world, which should, for the most part, fix these issues of us hitting these ledges, including in situations such as this one here with this little platform. As you can see, it works really, really well. And it doesn't really matter like where I place it, it feels pretty good and we'll be able to traverse pretty easily. So we're sort of clearing that path and making it easy to kind of get places. Um, and so that works pretty well and it's pretty in keeping with how the game works. Now, look, there's going to be edge cases to this and we don't have time to go over and make it the most robust thing in the world. But what we do have is something that's going to work for basically 90% of, I would dare say 95% of the issues that you're going to have. You're only really going to have problems when you're right up against something like this, and then it's probably going to block you at the top. Um, but then again, if you just space it out a tiny bit, you will get there. So it's not the end of the world, and it's definitely adjustable with some extra logic. Okay, so how does this actually work in the code? Well, it's really straightforward. The first thing we do is on our handle blink, we take the player off the ground, but we don't. We take the player position and we take it off the ground, right? So we start all of our conversations off the ground. And then we will do a capsule trace, one tick. The important thing to know is that we're taking the capsule radius and the half height from the player itself, if you remember, from begin play. The reason we do this is because if you try and cheat this by reducing the player capsule size or radius, what will happen is that this will be giving you a false positive that you can be there. What's going to happen is if you imagine that this is a wall and we're going to hit the wall, but our radius is half of what it should be, then what's going to happen is you're going to get blocked way too late into this situation. And then it's going to move you there, but then you're half into the wall, which will basically do that pop that kind of shoves you backwards. Now, there's a few things here that we need to do that will probably alleviate this. And one of those things is that we really need to start talking about the mantling that we can do. Both the mantling on edges that should change what the indicator does, and also the fact that where we're placing our blink like preview actor right now isn't really ideal because we're not actually taking into account the shape of the player. This sphere is going half into the wall. Can you see? That shouldn't be the case. That should be representative of where we're going to be. So it should be kind of there. You know what I mean? Like, so if you're looking at this wall, I'm saying that it should probably be here, but when I'm pointing this way. So that's kind of what we want. So something like this, so that we'll never actually, be trying to get inside of a wall. We're always going to be exactly where we would be like size wise. Hopefully that makes a little bit of sense. Um, so we have more things that we need to do. And just to finish up the conversation on this capsule trace, it's really quite simple. Like I said, we up ourselves by 200. Then we take that position, we add another 65, and then the position that we're going to try and check against, which is right in front of us, we just keep at the same height that we've done here. Now, this could probably be a variable, but I've left this like this so you can tweak it to your heart's desire. And that's basically it. Like nothing else is unchanged. We're just manipulating the trajectory. and this will give us really good results. Okay, so we have spent a really, really long time building this system, and we have a lot to cover still. So what I'm going to do is I'm going to stop it here where the movement is pretty solid, and I want to discuss what we need to do in the next section. The main thing we need to focus on is this preview actor. As you can see here, the actor itself will stay away from the wall, as I was showing you before, which will really help us when we're trying to get places such as this without any issues. Obviously, this is the finished project, as you can see, with all of the effects and stuff, but it really does help because then we're not trying to get into an impossible position. We're in fact trying to get just before it, which automatically makes it so that the trajectory is less difficult. And I'll explain, right? So if the trajectory isn't trying to get us, exactly to this point, but it's trying to get us to this point, it becomes a lot easier to come into here and do the trajectory to there. Whereas if you were more at an acute angle trying to get to here, you would struggle without hitting it, for example. So this is a really important thing that we need to do. The other thing that we need to do is that the functionality for the blink is really like layered. As you can see, as I move up, these spheres split and it shows you where you're going to be in the air, but when it comes down, they kind of merge together, as you can see here. There's also something that's happening here where you can see where we have edge detection. And when there is an edge, the indicator should change and we should mantle upon that edge. There's a lot here that's going on. It's a really complicated system. And so I'm going to break it down step by step, but I feel the best thing that we can do now is just have a break and have you implement the blink how it is. It's working pretty well, but you'll see that some of the hard coding that we did might not be necessary once we get to a stage like this. Now, we're still going to have potentially the same kind of problem here, but for the most part, it'll work pretty well. And that is the foundation of the blink system. In the next video, we're going to implement mantling, and we're also going to make sure that the object will be able to split, because that's quite important for our visual effects and shaders. Speaking of which, if you're interested in the full project, blueprints, Niagara, and shaders, I've linked them down below for you to check out. Thank you so much for watching. I hope you've enjoyed this lesson here at Hard Edge, and I will catch you in the next one. Bye for now.